Alright, welcome back, guys. This is going to cover measurement, how to do accurate, precise measurements, and it's going to go back over qualitative and quantitative data collection. It's going to be a review over that from the last video. So as a review, what is a qualitative measurement? Remember that L tells us that it's a descriptive term. Color, texture, anything that's going to describe it without numbers. Quantitative, if we remember, has that N. The N stands for numbers. So if it has a number, it's a quantitative measurement. So now here's an abbreviated list from the last set of notes that goes through these glassware items again. We're going to describe this as qualitative or quantitative. So if you want to quiz yourself again before the test, go right ahead. Remember, beakers, they're approximate. Remember, they're basically holding vessels, so they're qualitative. Burettes are precise, so they are quantitative. Erlenmeyer flats. Remember, we had two types of flats. One is qualitative, one is quantitative. The Erlenmeyer is qualitative because it's approximate. Graduated cylinders are always precise, so they are quantitative. And then pipettes, we're going to assume this is a graduated pipette. Because it says precise, so that's also going to be a quantitative. And then the test tube, remember this is a holding vessel, so that'll be a qualitative. And then the volumetric flask is the quantitative. So there's your quick review over qualitative and quantitative. So, when we're taking those glasswares, we're going to be asked to do a lot of measurements with those glasswares, both in labs and on tests and in everyday life. So when you're doing a measurement, you always estimate between the lines. If the measurement is on the line, you must add a 0 to show that you're estimating to be exactly in the line. You always include one estimated digit, so go as accurate and as precise as you can, and then estimate the final number, including that 0. When meniscus is present, remember a meniscus, if we have our graduated cylinder and it's full of water, remember it forms a little dip. You always take the measurement from the bottom of that dip, that meniscus, the bottom of it. Now, how do you tell the difference between a burette and a graduated cylinder? Because you're going to see some pictures, and if you don't know what you're looking at, you might think that the test has been labeled wrong or something like that. But you got to keep in mind the burettes, remember they're tipped upside down. Burettes measure the amount of liquid released through the stop clock, through that little twisty thing at the very bottom. The graduated cylinder measures how much liquid it is holding. So graduated cylinders count up like you would think normally, but burettes will always be marked upside down because they're measuring how much is released. So don't get confused if you see numbers that are marked upside down. So here we go, let's practice our measurement. So this one, we know the one's here, so this is definitely a 0.5, because we can go 0.1, 2, 3, 4, 5. So we know it's at least 0.5. Now we have to guesstimate. If this line is 0.6, then I'm going to estimate that to be about 0.52. And this is going to be in centimeters, so we'll call this 0.52 centimeters. Always give that label there. Now B, we know it's at least 0.7. So we're going to say 0.7. And it's going to be not quite close to 8, not quite 7.5. We'll call this 7.4, or 0.74. Oops, I'm sorry. That's right. Centimeters. And then C is way over here. So we know we have 1.5. So we know we're at least at 1.5. Now between the lines, so I'm going to guesstimate that a little bit over halfway. So I'm going to guesstimate that to be 1.58. And we will give you a couple of digits leeway on your estimation, so don't freak out about that. Now D is at least 2 and 0.5. Now we have to estimate. We can't just leave it at 2.5 because it looks like it's right on the line. We have to give that estimated value, and we're to say it's right on the line, we put in a 0. So 2.50 centimeters. E it's at least 3.3. That looks like it's right on the line there, so we'll do the same thing. We know it's 3.3. We're going to estimate that 0 right there. So it's on the line. F, it's at least 3.6, and it's almost to the 0.7, so we'll call that 3.6. We'll call that 8. So 3.68 centimeters. Okay, so that's how you're going to do a ruler. The big thing is always include an estimated number. All right. So now we're going to do a measure with our meniscus, menisci. So read the graduated cylinder. All we're going to do is read it. So if we had a line A, remember we take it from the very bottom of that meniscus. So if I erase that, get a little clear view of it. And we can see it goes from 30 to 40. So this is a graduated cylinder. So it goes 30, 31, 32, 33, 34, 35, 36, 37, 38. So at least know A is 38. And it's a little bit above the 38, so we've got to get that last estimation in there. So I'm going to call it 38.2. B looks like it's right on that line. So we're going to say it's at least 35.0. Now the picture on the right, on the bottom, is on the bottom of your notes. You see it went from 20 milliliters to 10. And that's what we're talking about, is counting backwards. So this is the burette. This one was a graduated cylinder. Repeat all that. So the initial, the 10 milliliters goes right here. Remember, we keep measuring it from the bottom. So it's 10, 11, 12. So we know it's at least 12. And I'm going to say that's just about halfway. So I'm going to say 12.5 milliliters. I forgot my units over here. Please don't do that. And then the next one, we know it's 13, 14, 15. That is definitely right on that line. So the final will be 15.0 milliliters. This is initial, and this was final.